Welcome everyone, I hope all of you are doing well. So in this video we will talk about Django and we will see how to containerize your Django applications using Docker. So if this is your first time on my channel, then welcome and I'm really happy that you are here. My channel focuses on software development and as well as on DevOps technologies. So if you want to improve your skills in one of those areas, then definitely consider subscribing to my channel. So let's get started. So first of all, you might want to run Django applications with Docker because it is easier to manage dependencies and configurations with it. And you can only benefit from that because it will help you to develop and improve your applications faster. So in a nutshell, Docker allows you to create an isolated process for any known application, which we call a container. Now, those applications will always have other applications that they are relying on, which we call dependencies. And as an example, if we take Django, then we can think about at least one huge dependency that it has, and that will be, of course, the Python programming language. So Docker is a software that can help us to create isolated containers, and then we will not have to worry about which server we run our Django application, because the main application and its dependencies could be packaged up to one environment. And by the way, that is a critical advantage that reflects big companies by the fact that they prefer to use containers instead of manually executing the application on a server. Now, if you want to know more about how Docker works because you are interested in this great technology, then I have a quick start video on my channel that I recommend watching, and it will explain everything you need to know to start with Docker. Okay, so I have a Hello World Django application here, and you can see on the right side that it is running, and on the left side there is the source code of the project. And I'm going to rely on that project to basically show you how you can containerize a Django application. Now, before we start, I'm going to assume that you have Python, PyCharm, and Docker installed. So if you are missing any of those, then check my description for the links to install each one of them. Alright, so at first, we're gonna need to design the image of our future container. Now, each containerized process will have an operating system of its own. Usually, it's a Linux distribution that is called Alpine, and hence we're gonna need to go to our project directory and create a unique configuration file that Docker could understand. So I'm going to select this Django Docker directory and not the subdirectory, which is a Python package. And then I'm going to create here Docker file like that. Now pay attention how I did not use any extension and I just named this file Dockerfile intentionally. That is a way that Docker will understand to read this file as its manifest file to prepare the image for the container that we will run in the future. So I'm going to press enter and continue. Now, when we create Docker files to define images, then there are tons of ready templates that someone already prepared for us. So I'm just going to use the best practice of a Docker file to spin up a Django application, and we will go line by line to explain what each line is responsible for. So I will start by this line, which is saying from Python 3.9.5-slim. Now, as I said earlier, each container is going to have an image that it is going to run based on that. So I just grab here a ready image from Docker Hub, which is a website for all the ready images that designed for us. And I just bring the Python 3.9.5 slim image, and that is just the latest version of an image that is existing by the time that I record this video. You can definitely change this to something like Python 3.10 or Python latest. This will also work, but I'm just going to use the slim version of this image so it will not take too much time to download it and it will not be the heaviest image out there. Alright, so the next line, it is going to be an environment variable that we'd like to inject to this image. And that's going to be the Python unbuffered environment variable set to 1. And that is just an environment variable that needs to be injected when we run Python inside another process because it will help us to see the logs on demand. And that is helpful when we run web applications. Alright, so the next two lines are going to be those, and those lines are going to be responsible to create a directory inside an image, and then it is just going to mark the working directory as this directory. Now you can see how I run just a command that says make directory code and then use this as a working directory. So that is all what those two lines are doing. And the next two lines are going to be responsible to declare the Python libraries that we'd like to install inside this image. Now you can see how I use the copy command, and then we copy some requirements.txt file to the code directory. Now this file is not really existing right now, but I'm going to create it, and that is just a convention text file that will allow us to basically declare our Python libraries that we'd like to install once we prepare this image. Now there are going to be some Python libraries that we'd like to install before we run the Django application, and for sure we're gonna need to execute a command that is going to look like pip install Django before we go ahead and run the Django web server. So that's why the convention is to create a text file that we will name it requirements, and then we will use pip install -r, and then we will just read the content that exists inside the requirements.txt file. So I'm going to again go to the project directory, and I'm going to create a file that I'm going to name requirements.txt, and then I'm going to say here Django like that, and that will be the only Python library that I'd like to install. Now we can also specify a specific version by saying equals equals to 3.2, for example. That will be just the latest version that exists right now by the time I record this video, so that is also an option. Alright, so now that we have this, then I'd also like to talk about this -- user. That is just going to be responsible to install this package in a home directory and not in a low-level directory that might require root privileges. So that's why we use here this -- user flag as well. Alright, so the last steps will be to copy the entire project to the code directory that we have created inside the Docker image, and then use a python manage.py run server command to basically execute our application. So I'm just going to use one more copy here and copy everything to the code directory. And then I'm going to use a cmd command, and that just marks the latest step of our Docker image, which will be to run python manage.py run server. So that is how our Docker file is going to look like. And now let's see how we're going to build an image and run container based on that build image. Alright, so I'm inside a terminal that is pointing to our project directory, and I'm just going to run docker build, and since the Docker file is inside this directory, I'm going to say dot here, and then we will tag this image with the name of Django dev. And that's because we try to prepare an image for Django development, so that's why I named it the way it is. Alright, so if we will run this, then you can see that we have built the image. Now this process might take a little bit more longer for yourself because I already have built tons of Django images, and Docker uses caching to build its images more faster, where each line in the Docker file is divided into a section, and if it recognizes a similar line, then it is just going to take much less time because Docker again uses caching. Alright, so now let's clean the screen and use the command that will be responsible to run the container based on that image. So I'm going to run here docker run, and I'm going to specify the image right here. So pay attention that when you use docker run, then the image name should be always the latest information that you put in, and in between you are allowed to specify special arguments like I do in here. So what I'm saying in here is that I'm using an interactive mode, and I'm also passing a flag that will be responsible to basically delete the container once we use something like Control-C or Control-Break to basically break the running container. And we need to do that because we cannot take for granted the fact that the container is going to be deleted once we exit it. So that's why we need to pass in those flags in here. So let's go ahead and run this, and you can see that we receive the expected output when we run a Django application. But actually, if we take this URL here and we will try to go to our browser and try to navigate through it, then you can see that we don't receive any response. Now, believe or not, that is totally making sense that we don't see anything in the Chrome browser, because this localhost IP address is only going to be available within the container. So what that means, it means that if we take the localhost IP of a running container and we try to access our own localhost of the server, then those localhost IPs are in both separated environments. So that's why we cannot think that this IP address is going to receive the connections. So the solution for that would be to somehow bind the connection inside a container to the host machine where the container runs right now, which will be my computer. So in order to customize this one, then we're gonna need to take a few changes in the Docker file itself. So I'm going to open our PyCharm and I'm going to go here and I'm going to change the default IP and the port that the python manage.py run server is running at. And I'm going to use a default convention IP that is used for binding connections. So it will be the IP of 0 4 times. And again, that is just a convention when you just don't know on what IP you want to run your server. So that's why you can just specify this default route, which is again the IP with 4 zeros. And then you can say that you only like to run your connections on this port 8000. And then we will have the option to bind the connection from our container to our computer. So we will see this in action just in a minute. But before we see this, then we need to open the terminal and rebuild the image because we changed our Docker file. So let's open our terminal and I'm just going to use Ctrl C here to exit from this container and I'm going to clean the screen and I'm just going to use again Docker build like we have used previously to override the previous image. So I'm going to run that and then I'm going to clean the screen again. And then I'm just going to pass in one more information in the docker run command that we have used previously. So I'm going to grab that and I'm going to pass in what kind of port binding I want to do now. So it is going to be by the flag of -p, and then there's actually a convention to specify to grab all the connections from port 8000 and bind it to the port of the localhost machine, which will be my machine. So for example, if we want to bind the connection inside the container of 8000 to 8001 on our host machine, then this will be the convention to specify that. So let's see this in action. Okay, so I'm just going to run that right now and press enter. Now you can see that now the logs of the Django is actually http 0000/8000. But this doesn't mean that this is the URL that we need to use in order to access our website. So besides, it is going to be the localhost of our own computer, of the computer that I'm working on right now. And since we binded all the connections to port 8001, then we're gonna need to access the port 8001 of our local host. So let's see this in action. So I'm just going to open our browser that we have been failed to connect to the website before, and I'm just going to try to access to 8001. And you can see that now it works. We totally see the connections and we totally see our website. And I just wanted to cover this topic very carefully because that is topic that I remember myself very struggling with it because I barely understood about how networking works in containers, but I hope that the explanation in the last few minutes were pretty much clear to you. Alright, so now that we understood this, then we might think here that this process actually slows our development lifecycle because every time that we change our code, even by one line, we're gonna need to build a Docker image and as well as running it. And every time that we will change the code of our web application, then we need to repeat this process. So that's just not beneficial. Although we use some of the advantages of Docker, we still want to be fast and efficient enough when we are in the middle of the development of our application. Now, it could have been a nice option if we could change the code of that isolated environment on the main rather than building an image and running a container based on that image every time that we want to see our changes. So to update continuously our container's content, we're gonna need to somehow tell that container to always use this as its inventory so that the container will always read from this path that our project is located at. Now, to really understand how this is going to work, we need to understand how you can store persistent data working with containers. So a container always needs an image definition to start successfully. But what if we inspect our container's file system and try to delete some of its files? Well, if we will do this, those changes will be gone when we delete the container, because all of the changes are isolated to that container. Now, I'm not gonna lie, there are multiple ways to solve this problem, like Docker volumes that you might have heard of, but to keep this tutorial straight to the point, then I will explain how you can mount this local path here into the container, which will also allow us to have persistent data. So we need to use a technology that Docker offers to us, which is binding mounts. So bind mount could allow us to persist data by mounting a path from the host machine to the container itself. And this option will allow the container to read its source code from the mounted path. And then we will see automatic refreshes on the Django web application as expected, because the mounted path will always be changed by us as the developers. Now, doing this on a Windows environment is a bit trickier than Linux host machines, because if you use a Windows styled path and try to mount it to a Linux container, then it might mess things up a little bit. Now, if what I have explained about volumes and persistent data didn't quite make sense to you, then I strongly encourage you to watch what I'm going to do hands-on just in a second, because the entire picture will be just more complete to you once you see this in action. Okay, so I said earlier that using bind mounts could be trickier on Windows, so I want to use a minute or two to explain you the settings that you might need to change in Docker desktop. So if you are a Mac user, for example, then you can skip this specific section. Alright, so I'm going to click on the running services in the taskbar, and I'm going to use right click on Docker desktop. Now, in the drop down here, if you see the option of switch to Windows containers, then it means that you are using Linux containers. So just leave it as it is. But if you see the opposite option, then consider clicking on that. Alright, so once you have done this, then we're gonna need to check our settings. Now, in the settings, we want to go to our General tab, and we want to make sure that the WSL2 is unchecked, because this is just going to make our lives harder when we want to use binding mounts. And the Hyper-V for that specific task is just going to make a better job, so I just don't use WSL when I work with binding mounts, and I use Hyper-V. Now, if you want to verify that your Hyper-V is running properly, then you can search from the start for Hyper-V Manager and click on a GUI that is looking like the following. Now, if you see a virtual machine that is named Docker Desktop with the state of running, then it means that your Hyper-V is set up perfectly, and it should be also responsible to see this Docker logo down below in yellow color, so it means that it is running. Now, if you have this option activated, then again I strongly recommend taking this off and doing restart if it asks you to do so, because again it is just going to be more smoothly working with binding mounts. Alright, so once you have done this, then please go to the resources tab and go to file sharing. Now, you might not see this file sharing option if you did not complete the previous tasks perfectly, so be sure to complete them, because otherwise you are not going to see the file sharing option. And now you want to specify what are the directories that you want to allow sharing with your containers. And you can see that I have used the CPython directory for myself, and you can directly share drives from here. So if you click on plus in here, then you can just share specific paths or just share the entire C drive. So just make sure that you select some directories to share, and specifically just make sure that your Django project directory is shared in here. And that will be everything that you need to complete in order to work with bind mounts in a Windows environment. Alright, so now that we have set all of this, then let's see what needs to be done from the Dockerfile side. Now, first, I want to show you what will happen if we were to comment out this line of copying the project directory to the containers code directory. So I'm going to use here comment sign, and then I'm going to go to our terminal, and let me quit this Docker container here by using Control C and cleaning the screen. So intentionally I'm going to build this image one more time. So I am going to use docker build dot and dash d Django dev. And then I'm going to use the same command like we did in this tutorial. So I'm going to clean the screen and I'm going to run this command which we have used previously. Now if I run this, then you can see that we receive an error that says to us that the manage.py file does not exist. And that is perfectly making sense because we did not copy the project directory to the containers code directory. So now what we are going to do, we are going to bind the path of our computer to the containers code directory, and that is going to look like the following. So I'm going to clean the screen again, and I'm going to use arrow signs to bring the latest command. Now let's see what are the arguments that we should specify to bind this local directory to the containers code directory. Okay, so I'm going to use here the argument of dash dash mount, and then I'm gonna need to specify a source and a target. Source being the local directory of our project in the host machine, target being the directory that we'd like to bind inside the container. So it is going to look like the following. So I'm going to say src is equal to, and then we're gonna need to specify the local directory. Now by convention we can use a system environment variable that is going to look like the following. So I will say twice percentage sign, and then I will use cd. Now for Linux users, this will be the system environment variable that is called pwd, and you should use it in that convention with the $sign and the parentheses. Alright, so now that we have this, then I'm going to specify the target by using comma, and it is going to be target equals to / code. And then I'm also going to use one more comma here, and I'm going to say type is equal to bind, because we are binding the source path to the target path inside the container. And now that we have all of this, then let's see what will happen if we run our container now. So we press on enter, and then you can see that our project is now running, although we did not copy the source code in the image definition. And there is a great reason for that, because the Docker container consumes the path from our host machine. So in order to test if this works, then I'm going to bring our browser and I'm going to refresh our page, and you can see that it works perfectly. We still see our application up and running. But now to the real testing. We want to basically go to PyCharm and edit some of the areas in our project to verify that this terminal is going to respond to our changes. So I'm going to open our PyCharm, and I'm going to now use those windows side by side so we can see that. And then let's just change a random area in our application. So I'm going to go to the settings of our Django application maybe, and just change something. So let me do it like that. And then I'm going to go here and maybe edit the allowed host, okay, just to have something being edited. And I'm just going to set this to everyone. Now, if I'm going to save our changes by Control S, then you can see that our application responds. So what that means, it means that we were able to create a perfect Docker image for development reasons. We still have the option to see the code being updated to our changes, and that is the behavior that you always want to reach to speed up your development lifecycle. Now, just for documenting reasons, then I'm going to bring here this command that we have used, and I'm going to paste this in our Dockerfile just so we can really remember what is the command that will be responsible to bind a host machine path to containers path. So I'm just going to say here something like use this command if you use bind mount. Then I will just paste this in like that, and that will be the complete Docker file. Alright, so I hope that you have enjoyed in this video, and if you have any ideas for other technologies that you want to see how you can run inside a container, then let me know this in the comment section so I can prepare more tutorials like this. Alright, so consider hitting the like button if you enjoyed in this one and subscribing to my channel. I will see you very soon.